So now let's go ahead and do the next problem, which is two sides of the length of the triangle are 23 feet and 32 feet. And we've got to figure out what other possible lengths of the third side. So again, we've got two possibilities. We've got the possibilities where the third side is not the largest side, and then there's the chance that the third side is the largest side. Okay, and again, let's let x equal the length of the third side. So in both cases, x equals third side. And let's come up with our inequalities. Well, if the third side is not the largest side, then 32 is going to be the largest, right? Because that's the larger one of these two. So that means the 23 plus the other shortest side has got to be greater than 32 by the triangle inequality. Now, if third side is the largest side, then these two sides are smaller, and so then our triangle inequality is that 23 plus 32 has got to be greater than x. Okay, so these are the two inequalities that have to be true at the same time. So let's solve the first one. Subtract 23 from both sides. That gives us x has to be greater than 9. Okay, that's our first inequality. And in this case, we get 55 has to be greater than x, or we could even write that as x is less than 55. It doesn't much matter. So our compound inequality would be that x has to be greater than 9 and less than 55. Okay, so that is the answer. That's one way to write it. We could say x is equal to 9 comma 55 with parentheses, showing that they're strictly less than, not equal to. That would be interval notation, or we could draw a number line. Okay, and the number line would be something like this. I'll just show you the main features of it. You have 9, lots and lots and lots of points, and then finally you get to 55, and it would be an open circle on each end and filled in between. So any value of x that lies between 9 and 55 will work and will give you a triangle that exists. But remember, these are strictly greater than. Cannot be greater than or equal to, or less than or equal to. X must be between 9 and 55, but not 9 and not 55. Let's go ahead and look at our last problem. And our last problem here tells us that we have lengths 12 feet and 12 feet. Well, okay, that doesn't really change anything. Let's go ahead and let's look at our two possibilities. So the third side is either not the longest, or the third side is the longest side. Okay, now if the third side is not the longest, then that means that 12, doesn't matter which one we pick, but 12 is going to be the largest side, or tied for the largest side. So x plus 12, which is one of the two sides, has got to be equal to 12. So that's that inequality. If the third side is the longest side, then that means that the two shorter sides, which would then be 12 plus 12, would have to be greater than x, which would be the third side. So these are our inequalities, and we can solve them pretty easily. Subtract 12 from both sides, we get x has to be greater than 0. Add these together, we get 24 has to be greater than x. So to write that as a compound inequality, we would write x has got to be less than 24, but has got to be greater than 0. Or we could say, in other words, with interval notation, x is between 0 and 24, but can't be either 0 or 24. And that is the solution to this type of problem.